Okay, in this problem, we are writing a polynomial of least degree for each graph. So we're going to talk about what does it mean for least degree that has a particular zero. So let me set up a problem for you. So let's look at this W. So knowing that this is a W, we know it has to be an even degree when all is said is done, and the leading coefficient should be negative. So we know that the leading coefficient is negative for the leading coefficient. And we know it should be a degree. It should be an even degree. So that's what we know just by looking at it. So let's look at the zeros. So the zeros are at -4, -1, and +2. And notice it bounces at +2. So when we write our polynomial, p of x or f of x, g of x, doesn't really matter what letter you use, a parentheses, we've got x -4, so that turns into +4. And then we have x -1, so that turns into x +1. And then we have x -2, since that's a 2, that's a -1, that's a -4. And it bounces. So the fact that it bounces means this has to be squared, right? Or it could be to the 4th power would make it bounce, or to the 6th power would make it bounce, or to the 8th power would make it bounce, right? So if this is an even multiplicity, or if it's an even degree, it's going to make it bounce of that. So it has an 8 even number of repeats. So the least degree means we want what would be the degree that would still make it bounce, but would be the smallest number. So wouldn't this have to be a degree 2 to still make it bounce? So remember when it's not bouncing, so notice it did not bounce at -4 and it did not bounce at -1. So this degree could be a 1, or it could be a degree 3, would still not bounce. A degree 5 would still not bounce, right? This could be a degree 7 or a degree 9. Those would all still not bounce there. So when they mean least degree, they mean what's the lowest degree that it would run through and not bounce. And so therefore this would have to be a 1 and a 1. And then as far as our a is concerned, we know our a has to be negative. So we know it has to have a leading coefficient of negative since it's opening down. And we're not given a value of the graph, so we're not finding a. So we're just going to assume a is 1 in this problem because they didn't give us an information of a point, and we're not going to pick a point because this is just like a sketch. So this is just a rough sketch. We don't really know if it goes down. We don't know how high up it goes or how low it goes. So it's not an exact sketch of the exact graph. It's more of just a sketch that is a graph that looks like a W and has those specific zeros. Okay, so your answer should be negative x plus 4 to the first power, x plus 1 to the first power, and x minus 2 squared. Remember, it has to be squared because it has to bounce. These have to be, so that would be your least degree. And then this is in factored form. So let's multiply that out and see what it would look like in standard form. So I'm going to multiply these two, and I'm going to multiply these two. So that's going to give me, and then I'm going to multiply everything by -1 afterwards. Right, that's those two multiplied together. And then remember, this is x minus 2 times another x minus 2. So be careful with that. When you foil this, you get x squared minus 4x plus 4. And then when you multiply those two, you can multiply them however you want. When I have a trinomial times a trinomial, I really like to multiply it out by using generic rectangles. And remember, we did this in the last video. So I'm going to pause it, do it, come back, and let's see if we get the same answer. Okay, so when you multiplied it out, is this what you got as your final answer? Notice that I have these are like terms, and then these are like terms, and then these are like terms, and then I had to, don't forget, we had to then multiply everything by a negative. So do you remember after you did all that, did you then multiply everything through by negative? Okay, let's look at the next few. Okay, so looking at graph A, let's look at the x-intercepts. And let's try to get a darker red there. So we got these x-intercepts. Notice the bounce. Notice where it goes through. So couldn't we write p of x, or whatever variable you want to write, and it's got to be, leading coefficient has to be positive 1. For my a, it has to be positive, and so it's x minus 0, x minus 1, and x minus 2. Aren't those 0 and 1 and 2 are my x-intercepts, or my zeros, and it bounces at 1, so doesn't that have to be at least 2 to get it to bounce? And obviously, doesn't the x collapse as an x minus 0? So wouldn't that just collapse to give you x and then x minus 1 squared and then x minus 2 for that polynomial? And then we'll go back and multiply it out in a little bit. Let's look at b. For b, don't we have it bounces at -1, and doesn't it run through at +2? So wouldn't my, in factored form, and isn't this have a negative coefficient because the end behavior is up to the left and down to the right? So isn't this got to have a negative leading coefficient, right? So it has to have a negative leading coefficient. So this has to be -1 times x plus 1 squared, because it bounces. Remember, minus a -1, that's where the plus 1 comes from, and x minus 2. So that should be the one for that one. So why don't we pause? Why don't you multiply those out, and let's see if you get the same answer so you can practice multiplying things out. Okay, so for this one, when you FOILed it out and multiplied it out, is that what you got? And for b, when you multiplied that out, did you get that? Again, there's lots of different ways to multiply it out. On this particular one, I went ahead and multiplied x minus 1 squared, and that's where I got x squared minus 2x plus 1. And then I went ahead and multiplied these two together, and that gave me x squared minus 2x. And then I multiplied those two together, and that's how I got that. So there's a lot of different ways you can do it, a lot of different ways. Okay, so then let's look at c. Okay, so on c we have the zeros. The zeros look like 2 and 0 and -1, and it bounces at 0. So wouldn't that be, and its leading coefficient is positive, isn't it? So the leading coefficient is positive. So we know a has to be +1, so +1. And then do I really need to write x minus 0 squared? Or wouldn't that just collapse to give me x squared? So I'm just going to erase that, right? Because it has to be bounce. And it's at 0, and the coefficient is 1, so that's going to be x squared. And then for this one, it's going to be x plus 1, and it runs through, so that'd be to the first power, and x minus 2 for +2. And notice, again, those would be either degree 1 or degree 3 or degree 5 or degree 7. Since we're talking about least degree, then these have to be 1s if they're going to run through and not bounce. That would be the smallest degree to have it run through. And then what would happen if you multiply this out? So if we multiply that out, that's going to give me x squared minus x minus 2. You should be able to FOIL pretty good. First side, outside, inside, last. And when you do your OI, double check that. And then so your final answer when you multiply that out should be x to the 4th power minus x cubed minus 2x squared when you actually multiply that out. Hate when I use the wrong thing. Okay. So why don't you pause the video and try the last two on your own, and then come back and see how you did. Okay, so for letter D, we have our x-intercepts. Notice it bounces twice, and notice that the W is headed down. So did you remember the negative leading coefficient had to be negative? So this is going to be P of x equals negative times, see that 0 is -2, so x plus 2, and it has to bounce, so it has to be a degree 2, or a degree 4, or a degree 6, or a degree 8, and since we want the least degree, it's a degree 2. And this one is at +1, so that would be x minus 1, and it also bounces, so it also has to be at a 2. And I'll go back and multiply those a little bit. We'll see how you did when you multiplied. This one has 3 different zeros. So it has 0 and 2 and 3, and notice it bounces at 0. So p of x, and it's a leading coefficient is positive, isn't it? Because it's opening up, so the leading coefficient is positive. So that's going to make it, can we just go x squared now? And then x minus 2 and x minus 3 because it runs through and doesn't bounce, so that has to be at degree 1. And then I'll go back and multiply it out and see if we matched. Okay, so did you get these when you multiplied it out? Hopefully I didn't make a mistake. Sometimes thinking and writing and trying to get the pen to work, so hopefully I didn't make any mistakes on that. And let's go look at the entire paper so you can see what we did. So if you want to kind of pause the video for a moment and look at each problem and see how everything's set up, so you can go from there. And that's how you write them of least degree when you're given a picture. Okie dokie. See you tomorrow.